So we have seen yesterday collection and collection methods. Now in that one of the method we discussed iterator method. Iterator method return type is iterator interface. So what is this iterator interface? That's what we'll discuss now. Iterator interface provides the facility of iterating the elements in forward direction only. So in one direction only, you can iterate them using this iterator method, and then you have to use iterator interface methods to access the elements. So there are a few methods are there in the iterator interface. The first one is a has next method. It just checks whether the element is present in the collection or not. If it is present, you can get it, otherwise you will get a false. So how you can use this iterator method is, see that iterator interface, it variable equal to collection name dot iterator method. You should not say iterator, iterator method. This is the function. So once you get that and you loop it while it dot has next. See, I'm using has next method here. So that means what it will check? Okay, this it variable has an element or not, it is checking. If this element has, so this it variable has an element, then you get that element with the next method. So what is the difference between has next to next to? Has next just verifies this has an element or not. Next method, it will fetch the value. So in the it variable, what value is present, it will fetch it. That's why I'm just printing. See, only return type method you can call in the print statement, right? So that's what a return type method I am calling. Next is going to return a value. So it returns the element and then cursor will go to the next element automatically. Then that will be taken and put it here. Then check that. So this loop will continue automatically. That's the next method and has next. These two methods only will use. There is one more method, remove method, but you won't use that. So these two are popular. So has next will check whether the iterator has elements or not. Next method will fetch that element. That is the iterator interface means. Even it iterates only in one direction, that to forward direction, no reverse direction. So that's the iterator interface means. Okay. Now, list interface. We already seen in the diagram, hierarchical diagram. So list is one of the sub interface of collection interface. And it contains index-based methods. It contains index-based methods to insert, access, and delete the elements. Collection methods is directly you are inserting the elements, accessing the, deleting the elements based on the element only, right? Everything. But the list provides the methods based on the index. You can insert, you can access, you can delete. So all the actions you can perform based on the index. So whatever you have seen, add method, add all method, remove method. So all those methods you will get here based on the index. You can insert based on the index, you can delete element. Based on the index, you can delete the elements. Based on the index, you can insert the collection. So all this index-based methods are provided in the list interface. So that's why when you already extended. Collection is extended to list. That means list can have all the collection methods. Collection is already extended to iterable. So this list can have collection methods, iterable methods also. List has a separate methods. What are those methods? Index-based methods. So list contains duplicate elements. List contains duplicate elements. List maintains insertion order. Which order you inserted, same order will be returned to you. Please remember all these points and listen the video more number of times. List is a sub-interface of collection. List allows duplicate elements. List maintains the insertion order. List so provides a methods to insert, delete, access the elements based on the index. That is a list means. List is implemented inside ArrayList class, linked list, vector classes. That means list methods, collection methods, iterable methods, all three collection methods are implemented inside the ArrayList, linked list, vector classes. That is this list. One of the collection type is a list. Another type is set. These two are very important for us. So see, you can see that we have seen an add method there in the collection. Add, this is the one, right? Element. Now this is coming from collection, and this one is a list collection method, this one. So what is this? Add int index element. See, same method name, but parameters are different. So that means this element will go and insert in the specified index. But this element directly you're inserting, but there is no option to insert in particular place. It will go and insert in the, where is the last element? Last place it will go and insert. But this one, forcefully you're inserting in this position. For suppose you have some element in the index, whatever, where you are inserting. Suppose you are inserting in one place, index one place. Already one element is, that element will move to next position. But this element will go and insert in that one position. So the first priority given to this add index in element method only. Whatever the element is there, automatically it will move. Shifting takes place. It will shift to next position. Even the element is there. If element is not there, directly it will insert. If element is there, that old element will shift to next position. The element which you are inserting, that will go and place in this position. So this is the add index. See, add all, this is coming from collection interface. But this add all is add all int index collection C. So that means you can insert this entire collection elements in this position. That's the add all method. Clear method is coming from the collection only. You know already clear method. Equals method, you know. Hash code method, you know already. This is a very important get method. So get int index, very important method, this one. Widely used method, this one. Why you will use this? To access list collection method, list collection element. Any list collection element, if you want to access, you have to call list collection dot get of and give the index number. In this index, which element is there, that element it will fetch for you. That's the get method means. So again, I'm repeating. Very important method, this one. Widely used method. Why get method will you use? To access the list collection elements. How you can access? list collection object dot get of int index. How can you access array elements? How can you access array elements?
Array and then use the index of the array to fetch it.
Right?
Yep.
So that is the array name, square bracket, index number. But here, how can you access the list collection elements? List reference object dot get method you have to call. You got the difference? Array elements, how we are accessing? List collection elements, how we are accessing.
Mm-hmm.
So you have to use a get method. Next, is empty method. It returns the Boolean value if the list collection is empty. Last index of. So last index, this element will be returned to. Say return type is integer. To array, it will convert the list collection into array. So you know already we discussed yesterday. Contains method, contains all method. Index of, you want to get the index of this element, you can get it. Remove. So you can remove based on the index. That means you can delete the element based on this index. And next, replace all. So we want to retain all, and we will use this set method. So you want to set this element in this index. Then you can use a set method. Get is accessing. Set is setting the element. So it is used to replace the specified element in the list present at the current position. So whatever the element is there in this position, that will replace with this element. That's a replacing. That's a setting. So that's the set method also. You will use one of the program. Remaining, you have so many other methods, but those are not that much important. Okay. There is one more list iterator interface. We have seen iterator interface. But what is a list iterator? List iterator is used to iterate or traverse the elements in backward and forward direction. In backward and in forward direction. So public interface, list iterator extends iterator interface. See, this is the one interface. This extends another interface. So interface extends another interface. So the parent of list iterator interface is iterator. So list iterator you can use to iterate only list collection. Why you will use list iterator? You can iterate in forward direction and backward direction also. So you have so has next to next methods, and you have has previous method. That's what the forward backward I told, right? Forward means has next to. And backward elements, if you want to access, you need to check first with the has previous. Okay, previous element is there or not, you need to check. Then you can get the previous element with the previous method. So these are the methods of list iterator interface methods.
So in general, sir, when we're doing this, do we always go for the has next and then do the next just so we check it first and then we fetch it?
Get it.
Okay.
You can get it with the next method.
Mm-hmm.
The value, whatever the value is there in this IT variable, right?
Mm-hmm.
That you can get it with the next method. Next method is returning the value for you.
Mm-hmm. But is it like mandatory to use the has next before we use the next?
Yeah, checkpoint is important, right? Without checking, are you going somewhere?
No, so just to
The
make sure, I just
availability
yeah.
check.
Mm-hmm.
Availability you check first.
Mm-hmm.
That's a proper way.
Mm-hmm.
If it is there only, then use the next method. If it is not there, how can you fetch it?
Mm-hmm.
So that's what. If the condition is false, then you don't need to call unnecessarily that method, right?
Mhm.
Waste of, time
Yeah.
and everything.
Mhm.
Unnecessary call is going, na? So you should not go that. Every second is important here in the coding. The call is going means some amount of seconds waste of time, right?
Mhm.
Yeah, that's what you can save that time, right? That's what the checkpoint is very.
Mhm.
Yeah. Any other questions?
But good so far.
Okay. So now we are going for the implementation classes. First, ArrayList class. ArrayList class uses a dynamic array to store the elements. So it basically inherits the abstract list class. So that means ArrayList is a class that is abstract list is an abstract class. Abstract class. And then, so these are implemented. These are, inside these things you are implementing list, collection, iterable methods here in the ArrayList. Basically, ArrayList implements the list interface. So ArrayList class can contain duplicate elements because list contains duplicate elements. ArrayList class maintains the insertion order. ArrayList class is non-synchronized. ArrayList class is non-synchronized. ArrayList allows random access because array works based on the index. That's why you can access randomly. Even ArrayList also you can access randomly. And so ArrayList class manipulation is very slow because of shifting needs to occur if you remove any element from the ArrayList. So that is the reason you will know the manipulation because, for example, one position, one element you removed, the next element will come to that position. So that shifting is taking place. That's why it takes some time. So the hierarchy, if you see here, public class ArrayList, extends abstract list, implements a list, random access, clonable, and serializable. So all these interfaces are implemented in the ArrayList class. So see that, so we have a constructor overloading this one. ArrayList class, this is a constructor, default constructor. ArrayList, you can give all the elements. ArrayList int capacity. So these are the three types of constructors we can use. So the methods is same. We already just now discussing the methods. I don't want to discuss again. Okay. So why do you use array when ArrayList is available? Right. So this is the one of the important interview question. So the choice between using array or ArrayList. So right, it just one is a dynamic array, like data structure. ArrayList, you already know that. Depends on specific requirements and which contains a lot of programming concepts. You need to understand that. So both arrays and ArrayList have their own advantages and also disadvantages, right? So let's see one by one. So use arrays. When you can use arrays? When you know the fixed size, so then you can go for the arrays. If you know the size of the data, you know exactly, then go for array. And you need to store and you don't want to change it. Then arrays can be a more memory efficient, slightly faster than dynamic data structure like ArrayList. So this is because arrays don't need to dynamically allocate memory. So that's the one fixed size is there, go for arrays. So performance critical applications. So like performance is more important, more critical. So every CPU cycle or memory allocation matters. Arrays can offer a better performance because They have less overhead compared to dynamic data structure like ArrayList. So primitive types. So arrays are ideas for storing the primitive data types like int, double, char, right? Float, long values you can store with arrays. But so ArrayList doesn't support primitive values. You cannot store them. So there is a boxing and unboxing concept in the this. So because in the array doesn't support boxing and unboxing. So which can occur when storing these types in the array list. So boxing and unboxing is one of the concept. Object you can convert into primitive. Primitive you can convert into object. That is the boxing and unboxing means. So those are the wrapper classes. You will get these concepts. So when you can use array list, when you never dynamic size you want to store, you don't know the size, better go for the array list. So because it's more flexible and convenient. Simpler APIs, ArrayList provides a more user-friendly APIs, ready-made methods. So that you can remove, add, manipulating elements, all that you can do with ArrayList easily. But you don't have methods in the array. So generics. So you have you can store the generic type of elements in your collection. So that avoids the runtime typecasting. You don't need to do. So that is the one other thing when you use a generics with the collections. Collection framework integration. If you are working with a Java collection framework, which includes classes like list to, set to, map to, so using ArrayList, so more easy to use them or their methods also. So interoperability. ArrayList can be easily converted to arrays using the toArray method. So providing compatibility when working with the APIs. So that require arrays. So that's the main reason why people will use. Please go through this. This is a very important interview question. Okay. So that's why